This is a more complicated example of a double replacement reaction. However, the overall concept is still the same. As you can see on my screen, I still have the first half of each compound in black and the second half of each compound in maroon. The black represents the cations. They have the positive charge and are always written first. The maroon represent the anions. They have a negative charge and are always written second within a compound. You might already spot a difference. The first compound has a subscript of a 2. The 2 belongs with the anion, however, notice that I have the 2 in black. The reason that I have it in black is because even though it applies to this anion, excuse me, even though it applies to this anion, the 2 is not innately a part of fluoride. For example, if I asked you, what is the formula for the fluoride ion? You would say it is F-1. You would not say it has a subscript 2. So then the point of this 2, what is that? Why is it there? Why do we include a subscript of a 2 if it is not a part of fluoride ion? Well, if you recall from previous chapters, every compound has to have an overall charge of 0. We know that calcium has a positive 2 charge and fluoride has a negative 1. So in order for calcium and fluoride to be in a compound, that means we must have 2 fluoride ions. So this 2 is only here because the fluoride is paired with the calcium. If the fluoride were paired with something else, this may not be a 2 anymore. It would depend on what it was paired with. So watch what happens in this type of double replacement reaction. Just like before, the cations move over to the product side and remain unchanged. The double replacement part comes in when we switch these anions. Something important to notice is that I did not drag the subscript over because that subscript is only there because of what the F is paired with. Now my fluoride is paired with a new partner. My fluoride may or may not have a subscript. We are not done with this problem yet because we have not answered the question about the subscript. We should go back to each compound and check whether or not the compound exists in a 1-to-1 ratio. Calcium's charge is +2. Nitride's charge is -3. That does not exist in a 1-to-1 ratio. So we are going to come and decide if I have +2 and -3, they both go into 6. In order to neutralize this compound, I need 3 calciums and 2 nitrides. Now my subscripts cancel out. Check out this additional compound. Aluminum is +3. Fluoride is -1. Again, this compound does not exist in a 1-to-1 ratio. If I would have dragged this 2 over to the right side and it said AlF2, that still would not be correct. The 2 is good if the fluorine is with calcium. Now the fluorine is with aluminum, so we need to think about what subscript do I need for my fluorine? +3 and -1. To neutralize this compound, I will need 3 fluorides. As you can see, this was a more complicated double replacement reaction because not every compound had a 1-to-1 ratio. That means after switching anions to get a new partner, you will always have to go back and make sure that your subscripts are written correctly.